Floating meeting controls. Okay. So I'm using Visual Studio Code, and I'm going to use cartopy via Python to make a map of some data that I have yet to determine what I'll actually map yet. But I'm going to make a new folder, just call it map demo, and then point Visual Studio Code at this blank folder. You guys can do however you want in your personal Python editor of choice. Make a new text file, and I'm going to save this as map demo.py. I spelled py wrong. Cool. Okay. Is everybody clear up to here? I know you're probably not. I'll help you afterwards. Yeah. I'll get you set up afterwards if that's okay with you. Yes, that's the goal of recording this also. Okay. Is everybody else up to speed on how to create a Python file? I'm gonna cheat and bring up old code over here. Yeah. Oh, that doesn't sound good. We're good? Good. Okay. So the first thing we're going to do is we're going to, first of all, decide on what data we want to plot. I'll probably just plot the last text file that Dr. Logan sent us, which this he just sent to, oh, it's in HLMA things. That's right. So I believe it's selected LMA MATLAB this file.csv. Y'all can go ahead and download this off the drive. Does everyone have access to the drive, or do we need to play pass the flash drive, which I don't have a flash drive to pass around anyway. I can email it maybe. Okay, so get this file, and once it downloads, can throw it in the studio. So I actually made a mistake when I was converting this file, as I've talked to several of you about, which is that it's comma space for all of them, and that's actually not supposed to be. So if you do Control F, and let me get this out of the way, and let me get this out of the way. If you do Control F, and then click this little thing for find and replace, you want to replace all instances of a comma and then a space with just a comma, because otherwise it's not really a real CSV file, and that's my fault. But does everybody follow that? No, a comma, you want to replace all comma space with just comma and no space after it. And it should look like this when you're done. Where everything's like tight. Anyway. The first thing we're going to want to do is import pandas as PD, because that's the import pandas as PD, because that's the library that is generally best for working with CSVs. I'm also going to take the liberty of importing from matplotlib import pyplot as PLT. And then finally, our new one for the week, from cartopy import CRS as CCRS. This is the cartopy coordinate reference system, which allows you to create matplotlib figures that are maps instead of just graphs. So I don't remember if everybody here, I don't know if y'all have oh yeah, you should all have cartopy. Again, you're going to want to select your atbo environment by clicking on the Python version at the bottom here, and mine didn't pop up for me, so I'm going to manually select. It is in your home folder, which you can get by going to downloads and then a command up on Mac. Windows, it's C users and then your username. And then yours will say mini forage, mine says Mamba forage, ignore that. Bin, wait, no, not bin. Environments, Atmo, bin, and then find Python. And select it. And now it should know, it should recognize the libraries. So I'm going to start off by reading in the CSV file. I'm going to call it LMA data equals pandas.read CSV, very similar to how we did a couple weeks ago. And then the file name, which I'm just going to copy paste out of the file name. And just to be sure that that reads in correctly, I'm going to do print LMA data and run it. So we get this table. This is kind of interesting, and this is an issue with Dr. Logan's stuff, I believe, which is that if you look in this file here, the first column is, I believe, microseconds since start of day. And after it exceeds, once it gets to 1 times 10 to the 11th, which 1 times 10 to the 11th microseconds is roughly 2 hours and 47 minutes. But once it gets there, it just does asterisks. And that's, I believe, an issue with the way that Dr. Logan is exporting these files. So that's why on your time series this last week, it drops off suddenly after 2 hours and 47 minutes and then just goes flat the rest of the time. So I need to talk to him about that, but we're just going to kind of ignore it for now, I guess. So what we can do is I'm actually going to bring up the code from a few weeks ago because a lot of it's going to be the same. 491 demos. This link is on Canvas, by the way. So if you guys want to go back and look at this, you guys can. So what we did last night was we read it in the CSV file. We set a start date. We did some stuff with time formatting, some more stuff with time formatting. We binned it into 5-minute data sets, created a figure, created an axis, and then plotted. And that was for a time series. Today we're going to do maps. So he didn't specifically say whether he wanted stuff binned or not. I'm going to go for not because it's easier. What do you mean? Yeah. Did you make a new folder specifically for this Python project, and do you have the CSV and the .py file in the same folder? Okay. Okay. Everybody else okay? I'm kind of trying to go fast because I feel like this is going to be a sort of a long thing, and I'm trying not to run out of time, but didn't? Okay, 1 second. Yeah. No, because like this is time series demo. Yeah, you need to make an entirely new. Okay. I'll just put a check in there. Yeah. If you want to do, what you can do is you can do reveal in Finder, and then copy this directory and paste it in there. It's now just in your downloads, but then you can point code that folder in there. Yeah, I'll see it. And then you have to do this. Or you just like the whole thing. What? Please. Yeah. And then where? Really? Like. All right, sorry, it's control F. Oh, yeah, control F. You click this little arrow, and then you do comma space. Whoops. Yeah. And then. Wait, that's just comma. Everybody else following? No, it says no. That's why you have to select your interpreter path. Well, yes, you do need to put down CSV, but you also need to select your interpreter path. Did you reopen it? And now. Print element. Oh, yeah, you have to print element data. Oh, yeah. But it's working, or it did give me an acceptance, so I'm gonna assume that that's gonna work. So once we have it written, we have our columns. We have A, which these could be better labeled, honestly, but we have one that's second fraction that we worked with last week. J is obviously latitudes and K is obviously longitudes. You can tell just by kind of looking at them that these are all latitudes of roughly Houston and these are all longitudes of roughly Houston. So we want to make a scatter plot of, I'm going to do all of these points, and then if we have more time, then we can get to binning, but binning gets a little difficult with images, so we'll get there. So the first thing we're going to do is basically just reuse this code from a few weeks ago when we did this with the time series, which is that this second fraction, it goes up to, how does that work? The second fraction is, I guess, the number of seconds since the start of the day, because that's how we did it before. So this is 14 seconds into the day, 28 seconds, 177. And at least according to the file name, the day is January 9th, 2022. So I'm going to set a start date equals, we need to import datetime from the datetime library. So from datetime, import datetime as DT. So I'm going to create the datetime object to reference the start of the day, which is going to be year 2022, month January, day 9th, hour 0, minute 0, second 0, microsecond 0. So this is midnight on like the first moment of January 9th. And then I'm going to say for num seconds in the second fraction column of LMA data. We need to make a new blank list. I'll call it pi date times. Now, this is very similar to what we did with the time series a few weeks ago, so that's why I'm kind of glossing over this. Equals blank list, and then we can say pi date times. We can say time of point equals start date plus time delta seconds equals num seconds. And we need to import time delta to do that. So now if I print, and then we need to append to the list of pi date times dot append time of point, and then print pi date times just to verify that that worked. That worked. So now we can, that worked too well, maybe. Shut up. Okay, it's still going. Just for reference, if it's ever doing that and you want to interrupt something that's currently running, if you press Control C, at least on Mac, and I think this works on Windows, press Control C in the terminal while something is actively doing that, it just immediately halts the process. So if something gets stuck, then you can do that. It's a nice little shortcut. But it does work. Takes a little bit, but that's fine. And now we want to create a new column for that. So I'm going to say LMA data. And if you index a column like this, I don't know if I explained this well last time. When you do LMA data and then a hard bracket, that gets you a reference to just a specific column, in this case, the one called second fraction. If you try to reference a column that doesn't exist already, pandas will create one for you. So I'm going to call it pi date times and equals pi date times the list. And then I can do print. I think I wanted to set index. This doesn't actually matter unless we want to do binning, which we'll do in a minute, but I don't know. LMA data equals LMA data dot set index to pi date times, which needs to have hard brackets around it too for reasons that I don't understand. It's set index, open parentheses, open hard bracket, open quote, column name. So that's just annoying syntax, I guess. And this Zoom thing has popped up again. So date times. And then if I just print LMA data, this is going to take a second because it has a lot of data to churn through. But there it goes. And we can see that we have our pi date times column, and these are date time formatted objects. Looks like it goes from 0 to 7 UTC. And yeah, it's the correct format for if we wanted to slice the array, which we might consider doing in a little bit. But for now, I just want to make a map. So I'm going to create a new matplotlib figure. I'm going to call it fig equals plt.figure. And then when we're creating our ax this time, last time we did something along the lines of ax equals plt.gca, which means get the current axis associated with this figure. In this case, we're not going to do that because we don't want the current axis associated with that figure. We actually want to throw it away. And we want to make a new axis that is has a specific projection, specifically one from cartopy. So I'm going to say ax is equal to plt.axes. And I mentioned last week that I don't like using PLT, but for Fig, you actually have to use PLT because you don't have a reference to anything at that time. And ax, if you're creating a new axis, if you use PLT, it is supposed to use the most recent figure. And in my experience, it usually does. Whenever I'm not creating a cartopy axis, I like using fig.gca because then I know it's going on this fig, but I'm definitely confusing a lot of people right now. This is making sense to everybody? No? Okay, well, I'm kind of ranting. It doesn't actually matter what I'm saying. So to create an axis that's a map, so you have your fig that you've just created, and then you need an axis to go in it. And the axis specifically can't just be like a normal graph axis, it has to be a map. So you're gonna say plt.axes and then use projection equals, and in this case, I'm going to use what's called plat Curie. So ccrs dot plat Curie. So ccrs references the cartopy coordinate reference system model. Plat Curie is a fancy name for a map projection, which cartopy map projections. They're well documented online here, cartopy projections list. But plat Curie is basically this projection. What it basically does is latitudes and longitudes are like 1 pixel each, or not exactly 1 pixel, but like 1/10 of a latitude is 1 pixel, or 1/10 of a longitude is 1 pixel. So the entire projection is based off of lat and lon, and there's no like transformations done to it. But if you wanted something like Albers equal area or azimuthal equidistant, etc., Lambert conformal, you could do any of those. And there are advantages to using these projections, but we don't really care what the projection is. We're just trying to make a basic map. And by using this plat Curie, since the map is in latitude and longitude and it isn't in some sort of weird projection, there's no math that has to be done on the data. And so it'll run faster. If you are using a projection like Lambert conformal where there does have to be math done to it, that math will actually be handled internally by cartopy. You don't have to do it yourself, which is great because it's difficult. But it slows it down a little bit. And yeah, if you don't have a preference for a projection, you should probably use plat Curie because it'll be faster. And then we're going to do ax.scatter. And in this case, I'm going to do HLMA data, not HLMA data. That was last week's name. It's LMA data. And I'm going to call so it's X and then Y for scatter plot. So if you think about X as your longitudes, which is kind of backwards because usually if we give coordinate pairs, we say lat and then lon, but matplotlib accepts lon and then lat. So kind of something to keep track of. In this case, lons are in the K column here. So I'm going to say K, and then latitudes are in the J column here. LMA data. We're going to say J. And then I'm gonna do fig.savefig output.png. And if we've done everything correctly, we should get a new file that appears here in a second. It'll take a second though. There it is, output. And we should have your map, which this doesn't look like much because it's a lot of data and it's not colored and we don't really have any like references to anything. So cartopy will also let you do things from like you can add borders and coastlines and etc. So yes.
What is the correct syntax for
Sorry.
the index?
I should have be sure that everybody got that picture. What?
Well, it's just invalid syntax. Invalid syntax. That's what I got right there.
Oh, it's a parentheses, not a curly brace. Sorry, I might have misspoke.
I just.
Yeah, also it's a, I didn't realize how bad that.
Either.
Did everybody else get the output picture? No. Did anyone else get the output picture?
Don't like second version.
I don't. Jordan, does your output look anything like that?
I can't even get mine right now.
Oh, okay.
So I don't know.
Well, I was hoping to check my method against your method, but
It's saying
Here we are.
When I'm looking at the variables, as I call on my lots of logs, it's just not even logs.
Oh, same right there. Hold on. Hold on, might happen. Hold on. Here, second correction. You go to choose before. So mine is third correction. Yeah, that's second correction. Like copy pasting.
Yeah.
Spelling it wrong. I don't think I'm spelling it wrong.
yeah. If you ever get that error where it says a column isn't found, you can print LMA_data.columns and run it, and it will print off the columns as Python reads them. So
Second correction.
see, it has a space before it.
Oh my god.
But it doesn't. Oh, but you see how it's unsaved?
Oh,
Yeah, if you have this dot, that means Visual Studio Code hasn't saved it. I have mine configured to autosave, so yeah,
I think control S.
I think probably in settings, auto
Yeah, that's
auto save. I'm gonna do it just on after.
I saved it. It's still.
Okay, well then you can print columns. So if you do print the column. Print. That's a file. That's interesting.
Nothing. I have an error in wrong direction.
Oh, well, we'll just see here. But secondly, oh, your Python file doesn't save. You want me to turn on auto saving here too? Okay, this way.
So I had. Saved it. I guess.
Yeah, well, but also when I was doing print, I didn't save that because I was used to auto save. Okay, so now it should work, except that we're getting another. Saying, additional argument.
that does work. And then ax equals PLT axes, projection. Oh, you have to have an open and closed parentheses here. You're calling a method, not referencing a property. So that's something that I should announce to everyone.
The Peyton's issue was, he had, did that work, by the way, Peyton? Did you get an output image?
Yeah.
Okay, it's just like a blue blob. Okay, that's fine. So, what I have here is I say PLT axis equals projection, CCRS.plot tree, and then I have this open and closed parentheses. And if you don't put this open and closed parentheses here, then it will fail for some very cryptic reason. But Python has a concept of having properties and having, so an object can have properties, which are things about the object, and then methods, which are things the object can do. And a lot of times they can get very confusing as to what is what. But if you're getting some sort of cryptic error like that, then kind of check to be sure that this is, if you're doing a property, you don't put parentheses on it. But if you're calling a method / getting it to do something, you do. So other than just experience, I don't really know how to explain how I know what are properties and what are methods, but it's, yeah, that's a thing. Is everybody else, who else is not getting this image?
Different.
Okay,
I have a different problem. It's not reading the file.
okay.
I'm just in the folder. I even looked at the folder. Well, I didn't do anything. It worked. I mean, it's creating and then saving the image. So it worked. It worked for you. I don't know. I just have the magic word. Bro, what can I say? It just works.
Where do you put cartopy?
Where do you what?
Where do you put cartopy?
What do you mean, where do you put it?
I just put it in here and it doesn't put.
Module name contract. Did you, same thing that I did. Yeah, you don't actually download Cartopy. You should have gotten it when you installed the library setup, the Atmo library. So I would just be sure that you're using the Atmo library or the Atmo environment. Yeah, that's it. That's the right one. So it shouldn't work. Oh, instead of CRX, we're CRS.
Oh, okay.
Yeah. So module name Cartopy. It's still running off of something other than the Python that they're going into use, and I don't know why. Like, I don't know Spider or not. So like, if I don't, Yep. So this is a way to print what executables actually.
Yeah.
I can't remember if that's a property or not. Also, I need to go up the Cartopy line. So you see how it's using at the local program spider Python.exe. It's not using the correct one. I don't know how to change that though, because the way that you looked, like it looks correct to me, but clearly it's not.
Now it's fun.
Can I actually see your friends next? Wait.
I was gonna say, I saw, Periscope, lighting images.
Should be.
I would know.
Yeah, I don't know. Like that should set it.
Where do you work?
I'm using Visual Studio Code.
Is that free?
Yeah.
Yeah, I'll get that set up.
I have the first video on Canvas.
Yeah.
Goes through how to set up videos.
I'll do that. I'll just keep writing the code.
Okay.
copy and paste.
Sure. So we have the map now, but the map is kind of useless because it's just a blue blob and a grainy square. So let's make it less useless. You can do this by doing ax.add feature. I think it is. Let me. Yeah, actually. I forgot the exact syntax of this. I'm not going to Google it though. Yeah, I'm gonna rip it from some of my old code. Let's see. It is ax.add feature. See, I was right. And we're going to add, I believe we want to add, I don't want to do US counties. Oh yeah, I should do US counties because that's actually useful. So US counties comes from MetPy, but it's a feature that you can add in cartopy. So to get this, you're going to do from metpy.plots import US counties, and US counties is all caps. And then you can do ax.add feature US counties dot with underscore scale. And I think one of the valid ones is 5 meters. Yeah. So I'm going to say 5 meters, and then I'm going to set the edge color to gray, just to make it kind of like not in the way of the plot, hopefully. The first time that you run this, and don't forget to import, or else this will fail, which I've done on line 7 here. From metpy.plots import US counties, and then ax.add underscore feature US counties with scale 5 meters, edge color gray. The first time that you guys run this, it will have to download a shapefile for the US counties. So it will take a second for y'all, and it might take a second for me. Yeah, see, it says downloading file US counties.shp. But if you look now, we have counties. I don't know why it is doing that. That's interesting. The other thing that I personally hate about matplotlib is that the default figure size is 640 by 480, which is not that high of a resolution. The way to override this is actually kind of bad. So matplotlib was originally designed for people making posters. And so the only way to set the figure size is to set the size in inches, not pixels. So it's fig.set size inches, and then width times height, but you can get a reference to pixels, which I use in almost every single one of my scripts. Yeah, it is. I usually define a variable called px, and I say px is equal to 1 over plt.rc params figure.dpi, which is dots per inch. For those of you who know anything about printing, which I didn't know anything about printing before I went down this rabbit hole of how to change it. But this is directly stolen from Stack Overflow. I don't know who wrote this originally, but then you can do 1920 times px and 1080 times px for a 1920 by 1080p image, which is probably what most people are used to. So yeah, that's kind of a oops, I stole this from Stack Overflow moment. But now if you rerun it, instead of 640 by 480, you will get a much nicer, much larger image. There it is. The lightning is still kind of all on top of each other, and also it's not colored, which usually I think XLMA does color by time, and so I usually try to do color by time. And we can do this pretty easily in that in our ax.scatter invocation here, we can do a, first of all, I'm going to set S equal to, S stands for size. I'm going to set it equal to 0.2 probably, just because all the points are on top of each other and it's really kind of annoying. So yeah, that looks better. It's still not great in that it would be better if we actually binned the data, which I don't think I'm going to have time for this week, but it's a very similar process to what we did the other time. Anyway, and then I'm going to set color, which is C, equal to, you can set color equal to an array, and it'll kind of figure out based off the min and max values of the array what to color everything. So I'm going to say color equals LMA data second fraction, because that goes based off of the second fraction. And then I'm going to say C map, which is basically what kind of color map do you want to use. I'm going to set this equal to rainbow, because that's the closest to what XLMA has. But Matplotlib has a ton of built-in color maps, and the default one is called Viridis. And all of these in here, Viridis, Plasma, Inferno, Magma, and Civitas, they're all colorblind friendly. So if you're using, like, if you don't have a particular preference, like I'm trying to copy XLMA right now, which is why I'm using Rainbow. But if you don't have a particular preference, you should probably use one of these, because it's more accessible for people with like disabled vision to read your plots and be able to understand them. So, but I'm going to use Rainbow because XLMA uses Rainbow and there's some familiarity factor with that. This could take a while. I don't know how long, but we'll see. I'm guessing that this hard break here is because Dr. Logan trimmed out that part. I'm not 100% sure. I'll have to ask him. But yeah, this is your data, I guess. If we want to do a color bar to better indicate the times, we can say this ax.scatter, we can store this in an object. I'm going to call it scatter plot, SCT plot. And then I can do fig.colorbar, and I'm going to say SCT plot, and I'll just leave it there. And it'll make an interesting color bar that's probably not the most pretty, but it's functional. Yeah, I'm going to go around and help people in a second. Okay. That's concerning. Yeah, that's concerning. So this is second fraction, which we can actually set a label on this color bar, I guess. By doing, I think it's label. I don't know if this works or not. We'll find out. Label second fraction. I honestly wonder if we have different data. That's all I'm going to say. Because I know that there's a lot of those files around, and yeah, okay, hey, the label worked. So yeah, this is flash plots, and now y'all know how to make a map. Did everybody get this map at the end? Did anybody not get this map at the end? You what, Chase? Okay, but does it work? Okay. Well, anyway, this will go up on the GitHub on Canvas shortly, and the video will go up shortly as well. Does anyone have any questions that everybody good? We all good? Okay. I guess if we have time, then we can do some binning. But basically, the way that I do binning with this is I would do a for loop. I would say, again, I'm going to reference back to this code from last week because we're kind of short on time and I don't feel like rewriting it. But 491 demos. We did this while current time is less than start of day plus time delta day is 1, etc. And then we binned it by 5-minute intervals. So we can just go ahead and use that again. First of all, last time I used, instead of start date, I did start of day. So I'm just going to replace all instances of start day with start of date, or whatever it is. And then instead of HLMA data, I just called it LMA data today. I probably should have called it the same thing, but if you just go through and replace all these instances. And then we had a list of times and equals list. And this list of counts we actually don't care about because we're not doing a time series anymore. So we can just get rid of that. And then instead of like, I don't know how to explain what I'm going to do, so I'm going to show it. I'm going to move this current time all the way down to the bottom and then indent everything that we just did so that all of it falls under the while loop. For output.png, I'm going to change output to a string, which is going to be called just current time. And then plus.png, whenever you call str, that means convert this object to a string. I don't care what the string is. Like, I don't care what the formatting is, just as fast as possible, make this a string. And so what this is doing is it's instead of calling the image, the output image output.png, it's going to call it start date, whatever that is, .png. And so we can get a whole series of images that are all different file names so that we're not like overwriting. And then where we did in scatterplot, where we have LMA data, I'm going to just replace this with 5-minute bin K, 5-minute bin J, and 5-minute bin second fraction. CMAP is still rainbow. This is going to take quite a while to run, but just because it takes you're drawing an image for every, oh, I did it wrong. Current time is not defined. We did current time, I believe current time was equal to start date to start off with, and then it gets added 5 minutes every time. We'll see what happens here. So you can see it's making an image for every 5-minute period in the plot. Yeah, we didn't set constant axis bounds, which would be good. So it's just using the automatic ones. So actually I'm going to Control C on this and stop that. I'm going to delete all the image files that I just generated. And then we can do the way to set, if you want to set a particular extent for like a particular latitude and longitude bounds on an axis, is you do ax.set_extent, and then open parentheses, and then open hard brackets. And then I forgot the exact syntax here, so of course I'm going to go steal it from some code that I wrote a while ago. Ax extent was, oh, and it's not even really correct here. It's latitude minimum to, wait. Hang on. That's a bad one to pull from. That's also an equally bad. Why don't I have any good? Shut up, Cole. Okay, all of these are terrible to pull from, so I'm just going to Google it then. So x at extent. Okay, so it is longitude minimum to, oh, what is it then? It's longitude minimum to longitude max, and then lat min to lat max. Is that right? Okay, well, that's good to know. And then in my previous scripts for HLMA stuff, I generally plot it on an extent of, I'm just going to reuse the same extent. So show me plot. A longitude minimum of minus 99.5, a lat. So I plot 99 minus 99.5 to minus 91 for longitude, and then 26 to 33.5 for latitude. I don't know if that's the correct syntax for what I'm trying to do here, but we'll find out in a minute. Okay, yeah, that's correct. And this is roughly the same, I think, as what lightning.tamu.edu uses-ish. So, so these are generating images once for every 5-minute period in the plot. And yeah, that's about that. This will take a little bit to run, obviously, because it has a lot of data to process, but you can see it's writing out the images as it goes. Yes? Yes, I can go back to the code, sorry. Of course, if you wanted to make this like actually done operationally, you could like add a title with the time and etc. But we did that last week and I don't really have time to revisit it. Is that about what you did with yours?
Yeah, but I used, so I couldn't get a lot of my stuff, my math plot didn't work, so I went to sleep more.
Oh, okay.
But it's a lot of what you're doing, but mine's just crashing right now, so I'm gonna work on it.
Okay.
It's not pulling from J and K on mine is just not working.
Okay.
So I'll figure it out.
Yeah. I honestly, I have not gotten as far into Seaborn as I probably should.
I couldn't get
Like-
this to work, but I'm looking back at my old code when I tried to do this.
Mhm.
It's some of it I am missing. And plus I didn't min it.
Yeah.
I didn't do that because I didn't.
Yeah.
So mine's just like one. When I did the scatter plot way,
Mhm.
he didn't like it that much, so he wanted contour. So mine's contour.
Okay, so that's like contouring. I was just plotting every single point. I'm assuming he was like contouring density or something.
Yeah, mine.
Um,
looks like that. This is for an old CSV that I did.
yeah, the
But
issue,
I didn't put in a second fraction. So you can figure out how to do it. So I literally plotted last and all. That was all I did.
okay,
But I'm trying to add it in, but it's not really. So
yeah, if you, so the way that this CSV is it's just a point for every single flash. And so, if you wanted to figure out a density, you would actually need to divide like number of flashes by an area. And that's kind of difficult math. If you had a flash extent density product, like from LMA analysis or something, or like if you use the McCall script that he talks about, that would do the same thing. But yeah,
I don't know. I just showed it and we were like, oh, it's good.
I'm gonna go ahead and yes, Peyton.
So someone's wrong with my indentation. You see why
Yeah.
it's not.
So you need to always have 4 spaces beneath, for everything under the while loop needs to have 4 spaces. And before it.
Well, of course, now it's. My things are very, but getting everything at the same day. Start of the day. Yeah, so I replaced start of day with start date. Like. And I just made a list called list of time. But actually, you don't even need to do that. The list of time
Yeah.
plus stuff that you use. They could probably just tell me how much.
Yeah, I cannot.
But neither of them do actually.
I don't even know.
No, like, I got it to be fitting, fitting every 10
What are you
minutes,
gonna
and the same data from the output, the entire day. Exactly, it's in a file.
That's why.
I use butter. I think it's fine.
Oh, so you're adding
I think
10 delta minutes equals 5 here, but then you're also adding 10 delta minutes 5 up there. Which, to be fair, I'm doing the same thing. So, oh wait,
So, like,
oh, you see how you have current time equals current time plus 10 delta minutes 5, and then you do it again here. Oh, you don't need to do it here. Or you can do it there, but they don't do it
Oh,
there.
nice.
Not sure. Trying to say,
What is this error? And why don't we hit this?
you know, I.
Yeah.
I've already released this. Right. I'm gonna go ahead and do it.
I'll put that up on Canvas and YouTube later today. Thanks for stopping by.